All right, let's just jump right in. For about 60 years now, we've all had this really stable, predictable idea of what a computer is and how it works. Well, guess what? That's all over. We are literally watching one era of computing end and a totally new one begin, right now.
And hey, don't just take my word for how huge this is. Here's Nvidia's CEO Jensen Huang, and he's calling these changes tectonic shifts. I mean, tectonic. So what's actually shifting under our feet?
Okay, to really get this, we've got to go back to the bedrock. For 60 years, the entire IT industry was built on this one solid promise. It was like the law of gravity for tech, a set of rules that were just always there. Super predictable, super stable, everyone could count on it.
And you can see that history laid out right here. It all started back in 1964 with the IBM System/360. That machine basically created the blueprint for everything. I'm talking the CPU, the operating system, multitasking, the whole shebang. That exact same model, that same core idea, carried us all the way through the PC boom in the 90s, right up until today. And now, it has slammed into a brick wall.
So what was the engine driving this 60-year-long party? It was Moore's Law. And this wasn't just a technical thing, it was a flat-out economic miracle. Think about it, you got a free ride. Your software would just magically get faster and cheaper every couple of years, and you didn't have to do a thing. You didn't have to rewrite it, you didn't have to re-engineer it, it was just free performance. The ultimate deal.
Yeah, but that ride is officially over. We have finally hit the physical limits of what CPUs can do. And this is where it gets really interesting. We've gone from that beautiful free ride of cost appreciation to a brand new reality, computing inflation. That's right. Now if you want more performance, you have to pay more for it. The free lunch is over because the old way just doesn't work anymore.
Okay, so if the old engine has stalled out, what's the new one? Well, it's a totally different approach called accelerated computing, and it was designed for one specific reason, to beat this new problem of computing inflation. So how does this thing actually work? Honestly, it's all about teamwork. You've still got the CPU, the generalist, kind of running the main show. But whenever it gets to a really hard part, a super intense calculation, it doesn't try to brute force it. Instead, it offloads that job to a specialist, the GPU. You can think of the GPU as this massive army of workers, all tackling thousands of little tasks at the exact same time in parallel. Then, once they're done, they just hand the finished, accelerated result back. It's really just common sense. Use the right tool for the right job.
And look, this isn't just some theory on a whiteboard. This approach is already out there, transforming, well, pretty much everything. We're talking real-time 3D graphics that look like movies. We're talking about gene sequencing, discovering new drugs, even optimizing these insanely complex global supply chains. This new way of computing is making a huge splash in basically every important industry you can think of.
Now, every new engine needs its killer app, right? The thing that makes it indispensable. For accelerated computing, that moment came about 10 years ago. It was a breakthrough in computer vision known as AlexNet, and it was the spark that ignited a revolution. It triggered the birth of something we now call Software 2.0.
And this chart just lays it out so clearly. On one side, you have Software 1.0, the old way. That's where human programmers, people, write code in languages like C++ or Python, and it's designed to run on a CPU. But now, look at Software 2.0. The creator? It's the computer itself. The method isn't writing code, it's machine learning from data. The hardware isn't the CPU, it's the GPU. And the output? It's not a program or an application anymore. It's an AI model, a neural network.
So this is the whole thing. If you take away only one idea from all of this, let it be this one. The software is now written by the computer. That's the paradigm shift. So if computers are now writing software, you're going to need a new kind of factory to make it happen, right? And that's exactly what these new systems, like Nvidia's Blackwell, really are. We have to stop thinking of them as just chips. They're not. They are massive, full-scale factories for producing one thing: intelligence. I mean, the jump in scale is it's hard to even wrap your head around. We went from a graphics card that you could literally hold in your hand, something that fits inside your home PC, to a single system that weighs 3,000 pounds and acts like one single gigantic GPU. It's absolutely wild.
And just to give you a sense of what that means, a single one of these AI racks, just one, pulls down 120,000 watts of power. I mean, that's not computer power, that's factory power. We are talking about something on a truly industrial scale.
So, if Moore's Law is dead, how do we keep getting better?
Well, we have a new set of rules to play by, new scaling laws. And it's no longer about shrinking transistors. Now it's all about data and time. First, you have the training law. It's simple. The more data you feed a larger model, the smarter the AI gets. Easy enough. Then there's the inference law. This says that after the AI is trained, the more thinking time you give it, the higher the quality of the answer you'll get back. It's a totally new recipe for progress.
All right, so we have these AI factories churning out all this intelligence. The big question is, where is it all going? What's the point? Well, it's heading towards two massive new frontiers that are going to change how we work, both in the digital world and, the real world. We're talking about agentic AI and physical AI. Let's start with agentic AI. The best way to think about these are as digital employees. Seriously, they're AI systems that can see information, they can reason about a task, and then they can actually take multiple steps to get it done. The analogy here is just perfect. You're not just buying software anymore. Your company is literally going to onboard a team of these digital employees, and their job is to make your human team way, way more productive.
Okay, so the second frontier is physical AI, and this is exactly what it sounds like. This is the moment AI breaks out of the data center and steps into our physical world. We're talking about AI that gets physics. It understands how things move and interact. This is the intelligence that's going to power the next wave of robots, self-driving cars, and fully automated factories.
And what's cool is there's this really elegant pipeline for how you build this stuff. It's a three-step process. First, you train the brain, the AI model, on a massive supercomputer. Step 2, you let it practice. You put it in a totally safe virtual world, a digital twin of the real thing, so it can learn and make mistakes without breaking anything expensive. And then finally, once it's graduated, you deploy that trained intelligence onto a tiny, powerful robotics computer, and you put that right inside the robot.
Which brings us to the end and to the biggest question of all. We've done it. We've built computers that can learn on their own, that can reason through problems, and that can now reach out and interact with the physical world around us. So the question isn't really, what can computers do anymore? The real question, the one we all have to answer, is what are we going to ask them to do next?